In today's video, we're going to be learning about what causes seasonal change. We'll start out the video by discussing why Earth experiences uneven heating throughout the entire globe, and then why we experience seasonal change throughout the year. So energy and light released from the sun take 8.5 minutes to travel the 93 million years to Earth. So Earth is very, very tiny compared to the sun. Here's our Earth, here's our sun, and as light travels away from the sun to get to Earth, it takes 8.5 minutes. Obviously, life and energy on Earth is all from the source of the sun. So areas at the center of the Earth experience the hottest temperatures. The north and south end of the Earth decrease in temperature. So in this area right here, we experience the hottest temperatures. And as you move further north and further south, the temperatures begin to cool. In the center of the Earth, we experience our warmest temperatures. It's a common misconception that areas in the center of the Earth are closer to the sun and therefore are hotter throughout the year. So often people will look at the globe and say, well, this area appears to be closer to the sun than this area or this area. So that's the reason that the center of the Earth is hotter than the north and south of the Earth. But that would be an incorrect conception, because in reality, the slight change in distance between the center of the Earth and the poles is not enough to change the climate. While it may seem like a large distance in this picture, when we're talking about the entire space between the Earth and the sun, it's actually a very small amount. It wouldn't give us the drastic changes that we see throughout the year. Rays of sunlight are made of packets of energy called photons. Each ray of sunlight that strikes Earth carries with it an equal amount of photons. So this ray right here, this ray here, this ray here, every sun ray carries with it the same amount of photons. So whether it's 200 million photons or 500,000 photons, whatever that number may be, every ray of sunlight and sun's energy carries with the same amount of photons. So here's the reason why different areas of the Earth experience different amounts of energy. So depending on the area that a sun ray strikes the Earth, the photon beam will either be concentrated in a small area, like right here, or spread out over a larger area. So let's say, again, that each one of these rays carries with them 20 million photons. So each ray is of equal strength. Each carries with it 20 million photons. Now let's say this ray strikes over an area that is 5 million square miles. And this ray strikes an area that's 10 million square miles. So now this same ray, they're identical in strength. Each one carries with it 20 million photons. This one, however, is striking over an area that's 10 million square miles in size, and this one is striking over an area that's only 5 million square miles in size. So if you were to do the math to find out the amount of energy reaching every square mile, 20 divided by 5 would be 4 photons per square mile. And this area is receiving 2 photons per square mile, 20 divided by 10. So this area is actually receiving less photons per square mile than this area, because this same ray, this 20 million photon ray, is striking over a smaller area, and this 20 million photon ray is striking over a larger area. So imagine the effects of a magnifying glass. If you take the light and focus it into a smaller area, the heat to that area will increase. You may have heard in the past about taking a magnifying glass and on a summer day shining onto a single spot and causing it to burn. What you're doing is you're taking the sun's energy that's coming in from all different angles, and you're using a lens to focus that energy into a single spot. So ordinarily these rays would strike vertically downwards, and spread out over a large area. But if you use a magnifying glass, you take those same waves, but now you focus them into a smaller area. And this small area takes all of that energy spread out and focuses it into a single spot. So the energy isn't increasing, but since it's over a smaller area, it can generate more heat in that small area. So there's names for these different rays. A ray that strikes over a larger area is called an oblique ray, and a ray that strikes over a smaller area is called a vertical ray. I will be referencing both rays as we continue. So now that we understand why the Earth is heated unevenly, let's discuss why we have seasonal change throughout the year, the reason for the seasons. So we've learned before why different parts of the Earth have different temperatures. It's due to the vertical rays striking over a small area and the oblique rays striking over a larger area. Again, all the rays from the sun carry with them the same amount of energy, but if they're focused over a small area, just like that magnifying glass, they deliver more heat per square mile versus the oblique ray. So while the orbit of the Earth around the sun is not perfect, it is relatively even. It never gets much closer or further away from the sun. So that rules out distance from the sun creating the seasons. We can argue that the Earth is relatively the same distance to the sun throughout its year. Yes, it does at times get slightly closer and other times get slightly farther away. But again, when discussing such a large area in between the sun and the Earth, small amount does not matter. Now, the reason we do have the seasons. The Earth's axis is tilted on an angle. So an axis is an imaginary line that cuts through the center of an object. All objects have an axis. The Earth's axis, in this picture right here, would be presented vertically or straight up and down through the Earth. This is how often we're used to seeing the Earth, in a straight up and down way. However, this is not what the Earth actually is. No, this is wrong. This is what the Earth actually looks like. Its axis is tilted on its side. So it is not this purple axis right here. The red axis is actually the correct answer. So again, this, incorrect. This is our correct image. It's tilted on a 23.5-degree angle. So the Earth is either pointed towards or away from the sun at different times throughout the year. Because of this tilt, we are either pointed sometimes towards the sun or other times away from the sun. The part of the Earth pointed towards the sun will receive more vertical rays and experience summer. The part of the Earth pointed away from the sun receives more oblique rays and experiences winter. So looking at this image right here, if you take an arrow and you see where the line is pointing, the axis, the direction is, and here's our sun, the direction it's pointed towards tells you what the season is. So the axis in the northern hemisphere is pointed away from the sun. So they're experiencing winter. The southern hemisphere is pointed towards the sun. They're experiencing summer. Yes, the top half and the bottom half of the Earth experience opposite seasons. So whatever season you're currently in, whether it's winter or summer, you can guarantee that the opposite side of the Earth is experiencing the other season. So if you are experiencing winter currently, the southern hemisphere is experiencing summer. Then the same works for spring and autumn. Now notice spring and autumn, the Earth is in relatively the same position because it's pointed neither towards or away from the sun. It's parallel to the sun. So this line is pointed neither towards or away from the sun. It's parallel to the sun. So that's why autumn and spring often feel very similar to one another. If you really think about it, spring and autumn experience relatively the same temperatures. But again, the same is true. When we're experiencing autumn in the northern hemisphere, here would be New Jersey right there. The spring, we're experiencing spring in the southern hemisphere. Now look here, let's draw our imaginary axis. Now in the northern hemisphere, we're pointed towards the sun and experiencing summer. And in the southern hemisphere, they're pointed away from the sun and experiencing winter. So the half of the Earth experiencing summer is also exposed to sunlight for more hours of the day, creating longer day lengths. The fact that it's exposed to sunlight for longer doesn't really affect the seasons, but it does explain why in the summer we experience greater amounts of daylight. So looking at this picture right here, you can tell, let's draw our imaginary axis. You should notice right away that the southern hemisphere is experiencing summer because it's pointed towards the sun. The northern hemisphere is experiencing winter, it's pointed away from the sun. So look how the sunlight lies. This side of the earth over here would represent nighttime, so we'll discard this half of the earth. Looking at the left half of the earth, notice the amount of sunlight reaching the southern hemisphere. This area right here. Notice how large this section is. This is the amount of the earth exposed to the sun during the summer because, again, the southern hemisphere is experiencing the summer. Now in this northern area, they're experiencing winter. You can see a much smaller pie piece during winter, so they're exposed to the sun for much less hours of the day in the winter time. That would explain why the days are longer during the summer and shorter during the winter. Now, of course, as the earth moves, going back to this picture here, as the earth moves, and now the northern hemisphere is experiencing summer, they would be exposed to sunlight for a longer period of time. The larger pie piece versus the smaller pie piece. And a good point to make while we're back on this slide, notice that the tilt never changes in this picture. It's always pointed, in this case, towards the left, to the left here, to the left here, to the left here, to the left here. The axis position where it's pointing never changes, but the position of the Earth does change. So finally, some terms you should be familiar with. We have things called an equinox and then a solstice. When the Earth is pointed either towards or away from the sun, we call it an equinox. When the Earth is either pointed towards the sun or away from the sun, we call it a solstice. So we have a spring equinox, because it's not pointed towards or away from the sun. You see the spring equinox or the vernal equinox coming up there, or the autumnal equinox. The solstice is when the Earth is pointed at an angle to the sun. So in this situation, you just saw the summer solstice, June 21st, or the winter solstice is December 21st. So pay attention to these dates. You will want to know them. They, of course, indicate the start of spring, the start of fall, the start of summer, and the start of winter.